Hello everyone. Today we're going to be talking about the first law of thermodynamics. So to begin, I want to introduce this concept referred to as internal energy. To explain this, I have a system here with three particles in it. Now these particles are moving around, and if you remember from physics, movement is associated with kinetic energy. Now, these particles are also experiencing a force of attraction or repulsion between them. Now, these forces are going to be described using potential energy. So, in this simple system with three particles, we have both kinetic and potential energy. So the total energy, or the internal energy, is going to be equal to the sum of kinetic energy plus potential energy. So now let's talk about a closed system. So in a closed system, we can have the transfer of energy between the system and the surroundings. The first law of thermodynamics says that this transfer of energy is in terms of either work or heat. So if work is done on the system, or if heat is transferred into the system, we will have an increase in the internal energy of the system. Conversely, if work is done by the system on the surroundings, or heat is transferred from the system to the surroundings, we have a decrease in the internal energy. In both cases, we either have an increase or a decrease, so we have a change in the internal energy. So work or heat can change the internal energy. So we could say that delta U, the change in internal energy, is equal to work plus heat. Now you might be curious what the signs are for work or heat. So if work is done on the system, or if heat is transferred into the system, the energy of the system is increasing. So both of these terms, when done on the system, will be positive. Now if work is done by the system on the surroundings, or if heat is transferred to the surroundings, then these terms will be negative, as the system is losing energy. Now I want to focus on heat. So as we just said, if heat is positive, it will be going into the system. We refer to this as endothermic. Now if heat is negative, heat is being transferred out of the system. We refer to this as exothermic. Okay? However, in both cases, to change the internal energy of the system, the delta U of the system, we have energy being transferred either into or out of the system. Therefore, the energy lost or gained by the system is equal to the energy lost or gained by the surroundings. So in this way, the internal energy of the system is equal to the negative internal energy of the surroundings. Okay, let's try a practice problem. So we have a system here, and we're going to add 300 joules of heat. Now, of course, this is a closed system. This results in a change of internal energy to 500 joules. And now we're curious on the work that's being done. Is the work being done to the system or from the system to the surroundings? And what is the magnitude of this work? To solve this, we'll use our equation. Delta U is equal to work plus heat. Then we're solving for work here, so we just subtract heat from both sides, and we get delta U is minus Q is equal to work. So we have 500 joules of work, or 500 joules of internal energy change, minus 300 joules of heat being transferred into the system, which is equal to work. So work is equal to 200 joules. And since this is positive, we know that work is being done from the surroundings onto the system. So work is being done from the surroundings to the system. And the amount of work that's done is 200 joules. All right. Thank you for watching this video. In my next video, I think I'll be talking about the second law of thermodynamics. If there's anything that you want to see in particular, please comment down below. Or if there's anything that I may have got wrong in this video, please comment also. Thank you.